In this video, we are going to see how to solve minimum size subarray sum question from the LeetCode. Given an array of positive integer nums and a positive integer target, return the minimal length of a subarray whose sum is greater than or equal to target. If there is no such subarray, then return 0. Here, we need to find out what is the minimal length of the subarray which whose sum exceeds the given target, exceeds or equal. So whenever we have given an array, we can find out all the subarrays of this array. If we consider all the subarrays of length 1 for this array, 2, 3, 1, 2, 4 and 3, this will become subarray. And similarly, if we consider the length of 2, then 2, 3 is a subarray, 3, 1 is a subarray, and 1, 2 is a subarray, and 2, 4 is a subarray, and 4, 3 is a subarray. If we consider subarrays of length 3, then 2, 3, 1 is a subarray of length 3 and 3, 1, 2 is a subarray of length 3. Any continuous part of this array can be considered as subarray. We need to find out what is the subarray which exceeds the target target value, which exceeds or equal to target value. Basically, we need to find the minimal length of the subarray which satisfies this condition. Minimal length of the subarray such that elements of that subarray sum should be greater than or equal to the target. Let us go through this example where we are given an array with 2, 3, 1, 2, 4 and 3. Consider this as the nums array and we have given a target as 7. And let us go through how this sliding window technique works. Initially, we will consider the first element 2 and we will check whether that exceeds the sum. The current sum will also become 2 and then we will consider 3 and written in yellow is the sum, and whatever we consider 3 and sum becomes 5. We know the target they have given as 7 and sum still is less than 7, and then we consider 1 and sum becomes 6. So our sum is still less than or equal to target, and then we consider the next element which is 2. At this point, observe that sum becomes 8. Once the sum becomes 8, we know that our sum is greater than or equal to target. So here our the subarray length is 4, and similarly if we continue our then once this condition becomes true, we will start removing elements from the front. So we will remove 2 and check the sum again. So once we remove 2, that subarray becomes 3, 1 and 2. And with this, sum becomes 6. So 6 is less than or equal to 7, and we will continue adding the elements to the right. So after 2, we will add 4. At this point, our subarray sum becomes 10, which is greater than or equal to target, and whatever I have written as target is actually sum. Instead of writing sum, I have written target. So once this becomes 10, we know that it is greater than or equal to 7. We will start removing elements from the front. So our subarray becomes 1, 2 and 4 and sum reduces to 7. At this point also our sum is greater than or equal to 7. So with this we will keep on, whenever this condition becomes true, we will always check what is the length so that we can update the minimum length. And consider this, once we remove 1 from the front, our subarray becomes 2, 4. At this point the sum becomes 6. So we will once again start adding elements to the window. So now our subarray becomes 2 and 4 and 3 and sum becomes 9. Instead of 9 I have written 7. At this point our sum is greater than or equal to 7. So once again we will start removing elements from the front. Then our subarray once again becomes 4, 3, and at this point we'll still check the sum. Our sum is 7, which is greater than or equal to 7. So we will once again start removing elements from the front, and our subarray becomes 3, and we have already reached end of the array, and there is no condition. Our current sum is also 3. There is no point in removing. Let us write code for the same problem using the same techniques as I have explained before, and we will start from 0, and let us end with 0, and initially end will be 0 because we are considering subarray length of 1 in the beginning, and we will minimum sublen, we will declare a variable, and we should initialize this to some maximum value in the beginning, and here they have given the maximum length of the array will be 10 power 5. So let us initialize it to 10 power 6. There will be 6 zeros, 1 2 3 4 5 6, so that this value gets updated every time. And here we are going through while end is less than len of nums, and we should initialize one more variable we need. This is our sum. So we will add the current number pointed by end to the sum. So nums of end, and we will check if our sum is greater than or equal to target. If it is greater than or equal to target, then we need to check what is the length, and we need to update the subarray length, minimum sublen. We need to choose. We should only update this variable if the current length is lesser than the previous length. So how to calculate the length? From start index to end index, the length can be calculated by end minus start plus 1. This is the current length, and this is the previous value of the minimum sublen, because we always want to update the minimum sublen value only when our current length is lesser than the previous value. Once we update this value, then we need to remove the starting element from the sum. So we'll remove the start, and then we will update this value. So we should continue this process not only once, but as long as this condition is true. So instead of writing a if case, we should write a while case. So once we complete doing this, then we have to increment the end, because we will keep on adding the element at the end. So if we don't find any such subarray, then this minimum sublen will always be this value, this very high value. So if minimum sublen is still equals to 10 power 6, which is 1 2 3 4 5 6 zeros, then we will return 0. Otherwise we can return the minimum sublen. So let us run this program and see and whether it works. Okay, all the 3 test cases are passing. Let us submit this solution. Okay, all the test cases are passing. Thanks for watching this video.